All right, guys. In the last video, we kind of introduced the idea of imaginary numbers. Um, and one of the main things we talked about, remember, was that I is the imaginary number. It's equal to the square root of -1. That's going to be convenient for us to use. Because basically what it does is it takes the square root of any kind of negative and just converts it into an I. And then we go about our day like normal, just using I in the problem instead of having to worry about a negative inside the square root. And another important thing to remember is that when we take I squared, when we square the square root of -1, that's just the same as just -1. And that's going to be important as well as we move forward. So don't forget, those two things are very key to this. All right, but let's simplify these in terms of I. This is kind of the bread and butter of what we really want to know how to do. So the square root of -25. Now remember, without imaginary numbers, this is impossible. This has no real solutions because what you're essentially asking is, what number could you possibly square that would equal -25? And there is no such number because anything you square would always be a positive, right? But we're going to simplify this in terms of I, in terms of an imaginary number. So what we're going to do, take our square root of -25. Just take the negative and separate it away from 25. If you remember when we did radicals, we could take the factors and split them up inside. So let's just say this is, the square root of -1 times 25. And it should all be under square root, right? Just separating the negative from 25. Now, if you part these into their own radicals, you have now two very easily simplifiable radicals. The square root of -1, remember, is I. We call that I. And the square root of 25, notice it's no longer, negative. Square root of 25 is just a normal 5. So you have I and you have 5, so you have I times 5, which we're just going to simply write it as 5I. To keep it nice and simple, 5I is how we'll write our answer. So it's pretty straightforward. It's just like simplifying any kind of radical. It's just you're basically taking the negative here, chucking it off to the side, and then calling it I, and then treating the rest of the problem as if it was pretty normal. So I don't like to think of it as difficult. I like to think of it more as just somewhat of an inconvenience that we have to deal with from time to time, but it's useful for purposes down the line. All right, so number 2, we have 5 times the square root of -121. Same thing as the last problem. What we're going to do is we're going to just take the negative, right, and separate it from the 121. I went ahead and put them in different radicals because I knew I'd have to do that eventually. So here what I've got, I still have 5. That's not changing. That's just sitting out here. The square root of -1, remember, that is I. We call that I. And the square root of 121, this is actually a perfect square. The square root of 121 is 11. So I have 5 times I times 11. Now, again, this is all multiplied. You don't see any plus signs or anything, do you? So it's 5 times I times 11, which you can combine. You can multiply the 5 and 11. 5 times 11 is 55. So this is 55. Oops. Again, don't know why it does that. Stop doing that. 55I is kind of our answer there. All right, now negative square root of -96. So ignore the negative on the outside of the parentheses for now. We'll just worry about it later. Kind of like the 5 in the last problem. It's just going to chill out there. So if you want to, you can think of that negative in front as -1. All right, but now what I'm going to do is I'm going to separate the negative on the inside from the 96. So square root of -1 and square root of 96. Now again, the square root of -1 is just simply I. So don't forget that's just going to change into I. And now square root of 96 is not a perfect square. If you remember 96, you're trying to find a perfect square that goes into 96. Oops. If you write out perfect squares, remember this goes back to pre-fall break stuff. You're looking for a perfect square that divides into 96, and that would be 16. You can split 96 up into 16 times 6. Do the square root of 16, square root of 6. And you can simplify this part, square root of 16, which is just 4. And the square root of 6 you can't simplify any further, so you leave it as the square root of 6. And don't forget, you still have -1 times I in front. So you have -1 times I times 4 times square root of 6. So in the grand scheme of things, the -1 times 4 will become -4, and there's an I. So really, we're going to have -4 I square root of 6. So that's just kind of a cleaner version of writing what I got here. Because -1 times 4, you can multiply them because they're both in front of the radical. They're both outside of a radical, so you can go ahead and shove them together, kind of like we did with the 5 and the 11 earlier. Okay. But it's basically a normal problem. A normal problem, the same thing we did right before fall break. The only new addition, the only difference is just taking this negative and calling it I. That's the only thing that's different. Otherwise, it's the exact same thing as what we did before fall break. Square root of -12. So there's nothing on the outside I have to worry about. But remember, you need to separate this negative from the 12 inside the radical because you can't do the square root of -12. Square root of -1 times square root of 12. So remember, this is just pulling this negative away from the 12. -1 times 12 is -12, but we're taking the negative part and throwing it off to the side, and then we'll simplify this. So square root of -1, remember, we same as always, that is just I. The square root of 12, well, 12, remember, is not a perfect square, but I can think of a perfect square that goes into 12, and that's 4. 4 goes into 12, right? It's 4 times 3. So square root of 4, square root of 3. Don't forget the I still chilling out there. Square root of 4 is 2. Don't forget the I still chilling out there. And the square root of 3 cannot simplify. So our cleaned up final answer is 2I square root of 3. All right, and one more. We have 2 times the square root of -36. This one's pretty easy. Let's first and foremost start by separating this negative from the 36. We call this square root of -1I, and we can simplify the square root of 36 is a perfect square. Square root of 36 is 6. So I have 2I times 6, which is just 12I, right? Because 2 times 6 will multiply to 12, and then you have times I. So you get 12I. Pretty neat and dandy. It's pretty helpful, but that's the bread and butter. You want to, if you ever forget how to do that, go back and watch that again and again, because it's important to kind of do things like that and try to make problems up in your own. You can always try that and work those out. So let's get to some of the mathy problems here. Solving a quadratic with imaginary solutions. So this is a baby quadratic. We're going to solve more complicated quadratics in the future, but let's start with this, where we only have a single type of x term. In the future, we'll solve problems that are actually like quadratics in the sense that they have an x squared and an x term. So something like this, something that we would have once factored. Or in this case, we'll use the quadratic formula for. But we're not going to get to those yet. We're only going to deal with problems that have the x squared, not the x part for now, because this is a little bit easier. As you can see, all we have in terms of x's are x squared. In this problem, we don't have any other type of x term, so it's pretty convenient and easy to solve. And here's how you do it. So you're trying to get the x by itself, and the first problem, the only thing I've got to get rid of there is that squared part. And the opposite of squaring x would be to square root x. So if you square root both sides, that'll clean up and leave you with x. But notice we have the square root of -81. And the square root of -81, remember to separate that negative from the 81 if that's convenient for you. This is going to become I, and the square root of 81 is 9, so we have 9I. Now, there's a little bit of a subtlety here, though. And we're correct in our answer is 9I, but it's really positive and negative 9I. So let me write that a little bit neater. It's x equals positive and negative 9I. And if you're wondering, why is it positive and negative? Why isn't it just not just 9I? Well, the problem here is because it's an equation, right? It's equal to something. So let me take you back to somewhat of a familiar problem and explain it from there, because explaining with the i's can be a little bit tricky. Well, let's say I've got the square root of or let's say I have x squared equals 16, right? Something easy to solve. You know that if you square both sides, you have x equal to 4. Well, that's what your calculator will tell you. But it's really positive and negative 4 when you square root both sides. Same as it was positive and negative 9i here. The reason it's positive and negative 4 is because both would work as x. 4 squared would equal 16. Negative 4 squared would equal 16. So x could potentially be both of those numbers. The same thing is true about this 9i. 9i squared and negative 9i squared are both going to be equal to negative 81. So just keep that in mind. That when you have equations and you square root those equations, you're going to have the positive and negative. It's easy to forget that sometimes, but we'll try and get ourselves in the habit of doing so. So we'll do it again on number 6. Let me write number 6 out off to the side so I have a little more room. All right, so we're trying to get x by itself. So first thing I'm going to do is get rid of the 75. I'm adding 75, so to get rid of it, I'll subtract 75. This leaves me with 3x squared equal to negative 75. Now I need to get rid of this 3, so it's being multiplied to x squared, so I'll divide it. I'll have x squared equal to negative 25. And now I've got to get rid of the squared. So I'll square root both sides, right? That'll leave me with x all by itself. And now remember, you would separate, just kind of pull this off to the side here, separate the negative from the 25. Now you should be able to kind of do this in your head, I would hope, because 25 is a perfect square. But the square root of negative 1 is I, square root of 25 is 5, so we get just 5i from that. But don't forget, it's positive negative 5i, okay, because we're dealing with equations here. So positive negative 5i. And then one more for the road, and then we'll call it a day for this video. We'll move on to another one, because this whole section is going to take multiple videos. All right, but let's do one more here. 9x squared plus 25 equals 0. So it's very similar to the last problem. We're just going to go ahead and subtract 25 to leave us 9x squared equal to negative 25. Then divide by 9, just like the last problem, divided by 3. We have x squared equal to... Now this doesn't reduce, and we're not going to leave it as a fraction either. Or we are going to leave it as a fraction. We're not going to leave it as decimals, what I meant to say. Just leave it as negative 25 over 9. There's a reason for that. Because we have to square root both sides in the next step, both of those are perfect squares. So just... I square rooted. Don't forget, the first thing I'm going to write down is plus and minus here because I don't want to forget that. But you can square root both of these kind of individually. So square root of negative 25 and the square root of 9. Now that's going to become 5i on top. Square root of negative 25 is going to be 5i. The negative part becomes I, and the 25 becomes 5. And the square root of 9 is 3. So we're going to have a positive negative 5i over 3 as my final answer. All right. I'm going to end the video here so it's not going to drag on too long. I'm recording this before we actually do it in class, so I don't know like what day we do what in class and how much we get done in class each time. But I'll just make plenty of these. But anyway, I'll leave you at that for this one. We'll carry on the next video with that. Haha, fancy. No, I'm just kidding. Complex numbers. So it's a good place to start for next time. All right. I'll see you in the next one, folks. Bye.